it is my latest experiment that I built here. This is the LCD driver here. Let me zoom in into it. You see those little tiny pins connected to this adapter, yeah, SSOP integrated circuit package, and it is connected to Arduino wires and to this LCD, this very small LCD, and it's working quite nice, I put here a a lamp that I made. Actually, it's two pieces of wire and a small LED, and I manually 3D printed with my soldering iron some plastic around that LED, and I made this head here, and it's powered at 5 volts, and it's having already a resistor inside. I'm not sure if it's even seeing through the plastic. No, I don't see. Yeah, but it's there. Yeah, probably it's this one here, but it is having a SMD resistor inside for the LED, and I'm using it for as a lamp in this case, and it's very practical. Here I have a voltage regulator, LM317, and I put 2 kilo and 5 volts here, and I use my multimeter here to get the the voltages, and it was 2.5 ish, not exactly 2.5, but somewhere around it. And the LCD was very dim, and then I figured it out. Well, I put this green wire that I'm having here is actually the voltage for the LCD. But this voltage for the LCD is actually getting inside this chip driver, so it's having a special pin for the voltage LCD, and this is the wire from that chip, and is with this wire I could probe anywhere I liked and test until I got some very clear digits there. It was here at 2.5 volts, and then when I took out this resistor, the voltage regulator didn't work like it should have been. You know, I destroyed the functionality of it, and it when you take out one resistor is outputting 5 volts. Actually, not really 5 volts, but like 4 point something, 4.5 ish. A little bit of drop because there are some transistors and some circuit inside this chip. This is an integrated circuit, actually. It's not a simple transistor, and I got a little bit of drop of voltage because of the components inside, and the LCD was getting extremely clear like it is right now. It was very washed up. The digits were disappearing when they were connected to 2.5 volts here, and then I did a quick and dirty voltage drop down voltage using these diodes here. You see 4 diodes. Theoretically, one diode is dropping 0.6, but these diodes, they don't really at 25 degrees Celsius, but right now is less than that. Or in special, I'm not so exactly sure when they are dropping that 0.6, because these are not really dropping that much, or because they are scrapped and they are not absolutely brand new diodes. They are dropping different values, 0.3, 0.4, but not exactly 0.6 like in the book, you know, by the book. It's not like that at all. So I'm having different values probably per each diode. I'm not sure. So it's not 0.6 for each of it perfectly. It's less. I measured with my multimeter here. I measured each voltage. I also probed at higher voltages, of course, and it's not recommended. But now I'm getting a 3 volts there. I cannot do it with one hand, unfortunately, because I don't have. Or let me do something. Yeah, I know how. So I custom made. This is a piece of sheet of metal that is solderable, and I bend it and I make it like a tube, you see, and then I solder it here on this side, and then I attach a simple pin from those long bars of pins, you know. And that's it. This metal sheet tube I folded around my probing pins here, and I can insert it and leave it there. Yeah. So now I'm having like an extension, and all that I need negative. Let me put it here somewhere, not to be in the way, not that close to that power. So here is the negative there. So with this guy I can probe. So you can see here 4.7. I'm not sure why I'm getting that value. Exactly 5 I was getting. I'm not sure why. For some reason I'm getting 4.7, but I was getting 5. Something is moving here. I'm not sure what, and is affecting a little bit. For some reason I'm getting 4.7 volts, but I was getting 4.8 volts right now. But I was getting exactly 5 point something volts. 5.2, but now when I'm filming, it's just fucking up, fucking with my movie here. So what I did here, I did a simple voltage dropper made from a couple of diodes. They are pointing towards, so from the power rail there, that's the positive power rail. You see, this is the positive rail and this is negative rail. So this first one is positive, and from the positive is pointing towards me. They are pointing like that, and like that, pretty much. Okay. If I'm measuring them, this is 4.33, 34. Here in this junction, I'm getting 3.9, and here 3.5, exactly 3.5. Wow. And here 3.1 actually it was, but now it got down a little bit, 3.09. But it was 3.10. Okay. So do you like my chip that I'm having here with all this wiring? Pretty cool, eh? And yeah, it is working absolutely fine now. I took this wire and I put it here. This wire is actually this green wire is the LCD power wire that is powering the LCD, but this wire is connected actually from a pin from this integrated circuit driver that I'm having here, and this is sending through these yellow wires and those red wires as well. Those red wires, by the way, are the four common, and this green wire is the power that is the LCD power that this chip is managing, is expecting. So this one pin from here is that LCD power, and this is its wire that is connected to that specific pin. And I probe it, I took it out and I probe it everywhere where I need it. And originally it was here on this 2.5 volts that I'm getting from this LM317 voltage divider, and then I built this drop down voltage that I just showed you. Or let me show you that I'm getting 2.5 here actually. Yeah, see, exactly 2.5. This voltage is from this voltage regulator. And okay, let me show you how it was looking before I get the good results that I'm getting right now, the quick and dirty one. And I hope, yeah, it's good, it's good. It's good. Let me zoom in. All right. So this is, you see how faint it is. It's only because of the low voltage that I'm getting there. So that's why I built this diode drop down voltage, quick and dirty, here. And it worked. It worked absolutely fine. It is working absolutely fine at 3 volts. This is under voltage. Here is completely under voltage, and here is optimal voltage. It is as it should be at exactly 3 volts. And voila, it's working absolutely correctly. Yeah, I'm really happy with this result here on this experiment that I did, and I will explain later how I made the program and how I'm. It's very easy, stupid easy. Actually, I did it in a couple of hours, but it took me a couple of days until I decided, until I read, until I search, and I did all the research. And there are quite a lot of data that you can get stumble. It's like a mesh of data, and it's a little bit hard to cut the right thing and to follow the right thing pretty much, because there are some, you kind of have the tendency to jump in too many directions, and that's a bad thing. And that's why it took me a little bit of time, like 1 or 2 days, until I decided what to use and what not to use. I'm still not happy with the driving modality that I'm doing right now. So I'm driving it through Arduino, but this is for testing only. And what we are seeing here is only purely as a test, not the final product, not the final driver. I want to actually drive it myself, not from a library, because this is a little bit of cheating, what I use here for a quick and dirty way of just to make it work, you know. And it is working absolutely cool, absolutely fine, and I love it. I actually love it. It's very cool that is working. Yeah, that's it for this part. I'll see you later when I will present the actual code, the actual links that I did here, and okay, I'll see you later. All right, bye bye.
All right, so this is how I started. I watched some movies and I find a guy here. Probably this was the guy. Yeah, this is it. And I watched his movie and he is explaining some stuff, but and it will help me on the long run, probably later. Right now, what I did, it didn't help me at all, because what I did here, I did a quick and dirty method of finding a solution to actually make it work, and I did. I'm very happy that I find this first quick and dirty solution right now. But I'll have to dig up the problem and to actually make it like this guy is explaining in his movie. What I actually did, I searched in Google for this chip driver, this IC driver that I'm having, HT1621 an Arduino code for it pretty much, and I got these results. I took a couple of links here. I didn't get that many, and I tested them and I looked in them. This what remained, this page from Arduino forums actually, or their official website, and it has, this is the driver library. This is the actual library here, and I downloaded it. This latest version that release latest version. Just click on it and it will, you see, it will download there. And after it downloaded, so I find 3 libraries pretty much for this specific chip. You see, 1621. Okay. So this is the library. So I will extract it, 7zip, extract blah blah. And this is what it is. On source, it means source code. This is the header, and this is the actual library that is using in the Arduino here. By the way, how to load this Arduino? You go to here to Sketch and include library and manage libraries. Okay, and after this window will open. To take a little bit. Okay, I had some problems with the recorder that I'm using. The boot recorder is called. When I open this window, library manager, this one here, when I open it, it stopped recording, and I was talking like an idiot, explaining how to find this library with the library manager. And pretty much all that I did, I write down this text, HT1621, and the only library that he got me, he find it, was this library by Valerio. And I looked in this Hello World example, and it is this is exactly like I'm having here. Also here, author. You see, author Valerio, new 5N44P. This is the exact name. And also here as well, Valerio new 5N44P, and that's it. This is how I managed to understand. To be sure, it's the same, exactly the same library that I was looking here in my source file. This is exactly the same library. So that's the modality, and that's why I'm showing here a picture because my recorder crapped itself and didn't like it for some reason. I did film with it other times and it didn't make me any problems, but this time I was, what the fuck? I was having multiple files, multiple see on C drive here. I'm having a lot of files here, but also these debut files that are saved in the local C drive directly, and there are many, and I erased them, and now it's fine. I cleaned them up, and this is the actual file that I'm recording right now, which is 0 bits, but it's stored temporarily in a temp folder somewhere in the Windows. And then when I finish recording, it will get the actual file size and the actual video. So that's so pretty much it was having a couple of files here that was they were very small, a couple of bytes probably. All right. Use it here. I included it, but before I will get into this side, let me show you the actual file that I downloaded from here to look a little bit inside and see how it's looking, or open it with my yeah, it's good. This is Visual Studio 2010, and it's a very good file, especially for C files. It's having a very nice color marking for everything. I really love it. I am very used to it right now. So this is the inside of the file. What is having pretty much the main characteristics of the library. Pretty much what is it is using this header. .h, you see, header. This h header is this guy here. And if we are looking inside it, we see a lot of declarations, and that's it. This is the header, what is saying, and is defining something. That's a bit more complex here that I don't understand this part, but this is declaring some void, some integer. These are variables here, private variables. These are methods or functions, all voids. They are not doing anything. They are auto executing pretty much when you use it in code. So these are variables here. Also this one as well. On this one, variables. These are methods, or yeah, including the last one. But it's only the declarations of them. So this is these two files, what they are containing inside them. Actually, this is the library itself, the C++ CPP file, and inside what. Well, it is using this header first of all, and the methods and the declarations that we've seen inside that header, and some of them probably, but is also creating its own method or function here inside this library. So this is function 1, this is function 2, and so on. This is another function, so on. And when we finished all the functions that are made, this is the switch case. It's special characters that he is using. Okay, but that's it. Pretty much this is declaring some functions inside, or methods, or whatever you want to call them. These are the inside, how they are looking inside for each method, and you can copy it and use it in your code. No, of course. We can close this file because we looked there. So this is what I did. I looked inside it and I was sniping for the code, the code that is making it work pretty much. Yeah, this is his project that he used, his LCD that he used, and it worked fine. Very cool images that he put there. This is another library made by someone else, but I really liked how he was explaining the things, why, and please read everything that is here, and what it is, and how to use it. So and I also looked on all these links that he is having here, and it didn't help me that much. Most chips are from Holtec, but any 40, actually this Holtec brand, I got mine from another one, but probably it's the same thing. But any 48 pins is SOP. Yeah, you see, yeah, my chip with 1621 in its name is probably an HT. So my version probably is an HT, as he is saying here. Very interesting. But let's go back and read a little bit of this, because so based on the bit banging efforts by Angzo, so I read somewhere else that pretty much the code, what is doing internally, this library, what is doing inside it. I didn't stay and get too much into detail inside it. I didn't literally. I did read it a little bit, and I did understood something, but not in too much depth. I didn't get it from the first until I read it here. That pretty much you are bit banging every segment of the digit in the LCD. So yeah, that's it for this part. With what how deep I go to search for something that I'm interested in, and how much you can find about it. How many information you can find, and it's probably is good enough what I find here. So let's get back to Arduino program itself. What I did here, how did I manage to write this functional code that is actually running that driver? I got here in the examples, and I got directly to hello world, because hello world is the simplest possible, and I didn't even look on the others because they look complicated. So I got here and I open it with a text pad here, and he this is a comment here between this element and this element here. So all this is a comment. It's not part of the code, but this is part of the code. This is starting. This is the beginning of the code with this included. And what I did, let me show you mine. What I did, where you know, I changed. He had these pins here for cursor, vr, and data, and I had them as well, cursor, vr, and data, and what they are meaning. And I only changed the number from the Arduino pins, pretty much. So I carefully looked on my board what links that I made there, because I built this circuit and I leave it for a couple of probably months. I leave it like that, and I couldn't remember shit what connections I did there. It was staying and waiting for a very long time until I decided what to do and how to do it. So I looked closely what pins from Arduino are going to what pins of the to their respective special pins on the driver. And let me show you the picture, because I did look here. I have these red markings that I'm having here. This I know exactly what they are doing, but these blue markings that I'm having, I'm not quite sure what they are doing. At least I wasn't in the past quite sure what to do with them, but I linked them anyway. I put a wire from Arduino to these pins as well, and everything else I connected this segment from 0 to 5 here, and this commons from 0 to 3, which are 4 commons, and this 6, they represent 10 pins for the LCD. These are the wires that are going directly to the LCD. This VDD is the power for the chip, plus 5 volts, and this VLCD is voltage for the LCD pin. Like I mentioned before, it must be 3 volts, because the LCD in its datasheet that I collected it from AliExpress page. You have to look on the details of your component on the AliExpress page, and there I see this specified all my LCD that I bought from as a component. As a single component. I have only 2 LCDs from AliExpress that I buy, 2 types of LCDs. One is a static LCD with many pins, and these are multiplexed LCD that I'm driving right now with this chip. And they both, these 2 types of LCD, they both work with 3 volts, both of them. Very easy to remember them by that. Is exactly what I did there. I used those diodes, and I got that 3 volts, and that's it. It's working. It's fine. The contrast is good enough. Is very good, the contrast. This VSS is the negative rail, is to the ground. It's a minus there. I put. This I didn't know what they are meaning, what they are doing. This buzz, it means the buzzer, and 200 and 400 megahertz, kilohertz, whatever, kilohertz probably. But I don't really care about them. All that I care right now is to make this LCD work, and it did work quite well with this specific library that I'm having here. That I managed to install it and run it, and fantastic. And then I read the datasheet. I read the datasheet quite extensively, and the datasheet, this is the datasheet here. Like I said, this is the brand HT1621B but the other guy said on that file it's from Holtec or something. And this is another brand, HT1621B. It's weird. It's a little bit weird. Probably it's a subsidiary factory or something. Is something of a factory in another place, but from the same brand. Who knows? But this is the datasheet that I got. What I wanted to show you. And I did it extensively. Actually, I did it like 2 or 3 times. All these functional descriptions. I avoided this system oscillator. I didn't read it at all because I don't really care. Because I understood that this chip is having internal oscillator that is doing what you see here. On chip RC resistor capacitor oscillator that is beating at 256 kilohertz, and is good enough. Is super good at this frequency, and it's driving fine the LCD at this frequency. And I trusted it, and I didn't want something external at all. So I don't care of the watchdog timer. I didn't really understood what this IRQ means, and it turns out this IRQ here, Arduino pin 4. It means this interrupt request. But this is more from computers. This is an optional in-out probably, or only output. I'm not sure. Yeah, it's like an output that you can read what the hell is going on. It's an optional interface to the chip, pretty much, and you can use it whatever you please, as a clock, reading the clock inside to read the memory probably. I'm not exactly sure, but I believe it's something very general to do with it whatever you please, pretty much. It's not designated to any specific function. If I'm right. If I'm not right, then like I said, I'm not very used to this IRQ, what it means, but this is my impression. This is how I'm seeing it. On this RD, it means read the clock input data. This is for a special function that you have to use inside this chip when you actually write and read from the chip. Write to the chip and read from the chip. And so I put them to not used. So this, and I remained with these 3 pins, only these 3 pins from the chip to use. And how did I know which pin is this designator? I looked here it is. It is saying there, you see? In the datasheet, let me use this. So CS is pin 9. So it's pin 9 for the CS, okay? So pin 11 for the URU. So URE is pin 11, you see, and pin 12 is data, and immediately this is data. And this is how I read all these pins. This is how I link them to Arduino, to pin 0, to pin 2, and pin 3. And then from Arduino, what else did I link there? That's it. I linked actually this one as well. This RD is linked as well, and this IRQ. So I'm having 5 wires there, but these are not used at all. I didn't know what to do and how to use them. But in the end, it turned out they are not used at all. And what you've seen on the breadboard there, I should have only 3 wires instead of 5. Okay, I'm not exactly sure how to link them, so I didn't link them like I'm saying here. Set IRQ as 0 if not used, and also here a 0 to the ground with a link to the ground to ground them. But probably they are grounded internally with a pull down resistor or something. It should, and it's fine to leave them floating most probably. So that's the pins of the chip, the driver chip, and the Arduino pins. What they are doing. So this is the hello world. So what I did, I took from this hello world this very simple code that is having. Note that this here is a comment here with the double slash lines. This is my code that it worked for me. I also renumbered and I rechecked my pins to be, and I used his code here and his comments in my version that I'm having here. Yeah, of course you can use whatever pin from Arduino. These are from Arduino 0, 2, and 3 that are going, but it's not. And this is what he meant as well here to its Arduino device that he was using, or whatever controller he was using, probably Arduino. LCD. So LCD begins. So he is actually saying here. He commented, if I'm not having a backlight, an LCD that is using a backlight, he made a special function here. So this function is working for him with this last number 10. That is for the backlight. But he also made this secondary function that is not using the backlight data. And it's simpler, and it's exactly what I used here. Exactly, I'm commanding only CS, this guy here, VR and data, and that's it, without that backlight extra input to keep it. And exactly is what I so this function I didn't have to include it in my code at all because I don't have a backlight as I said. On LCD clear, and that's it. And then the loop that is containing only these 2 lines, actually this line. And actually this line, because the rest is a long comment descriptive what this line is doing, and he's dividing by 1000. But I'm dividing here by 100,000, you see, 100,000, because I did it with dividing at 1000, but it was running very fast, and I was saying 888 pretty much. Not really. The first digit was running fast, but not too fast, and I could see the actual digits how they were turning. So that's why I put it a longer time pretty much, and I could have change the delay here instead of here, but I did it here because it's milliseconds, which is timing. The time, how many milliseconds to keep it on the screen, and this delay is wait 1 millisecond between changing to the next number pretty much. So this is timing, and also this is timing as well. 2 timings, how much to keep it on the number printed on the screen, and how this is the pause between the numbers, and that's it. Very extremely simple. I really like this code. Very easy to do it, to implement it, and it worked from the start without any kind of errors. Fantastic. So good job to this guy Valerio. No, it was his name probably. Yeah, it says here by Valerio. Yeah, in 2018. Good for you, guy, dude. Right now is 2024, 2023 at the end of the year. So it's the beginning. In a couple of weeks is the beginning of 2024, and 2024. So how many years? 6 years. So he is telling me this I'm getting this old 6 years code that is working absolutely fine and perfect. And I'm very happy that it is. So this was a quick and dirty way of making it work. But what I really want to do, and this was the plan from the beginning, is that I want to make the bit banging code that is sending the bits and the data and all the logic to the LCD and to the driver and then to the LCD. And now that I figured out the voltage, that was a problem with the voltage in the very beginning, if you remember. With 2.5 volts, it was very dim, and now it's at 3 volts exactly, and it's quite good, and it's optimum right now, optimized. Now I'm looking at it, and it's still working. All this time that I was talking here, I leave it there to work, and it's counting exceptionally good. And yeah, I will see how I will make that bit banging myself. I hope I can do it. But if I cannot do it, at least I have this quick and dirty sample that I'm having here, and I can extrapolate from this and probably use it with other devices. Most probably, I already have actually a very cool, very interesting device that I didn't use it that much, but I'm not sure if I can use a PIC microcontroller because I don't have this library. I'm dependent on this library that is working only for Arduino. That's why I want to make it myself, that library, that bit banging, to actually use it with a PIC microcontroller or with digital logic if I can, NAND gates and whatever. Hopefully it will be possible, but I have to dig out how to do it. And if I will discover how to bit bang the code myself, so practically I will make use of this guy, this Valerio library. I will make use of it, and I will look inside it, and I will use some parts from it, and hopefully I will figure out myself how to do it myself based on his code. And if I will manage to learn that, part, then I can extrapolate and make my own PIC microcontroller code, and also a logic circuitry from logic ICs, pretty much. And we will see after that, even if it's possible. I'm not completely sure if it's possible, but this is it for now. I hope you like my project and how I managed to make it work. And unbelievable, it worked very, very smooth and direct, and it was quite easy. Beside all my expectations, I was very, very sure I hit the fan. You know that expression, the shit hit the fan? It's how hard I was thinking on how to do it. I was thinking on the hard way how to do it, how to drive this LCD. But it turned out unexpectedly, I may add, very unexpectedly, unpleasantly to work with. Actually, this library saved my ass pretty much. Many thanks to this guy Valerio, whoever he is. Many thanks from my side, and to all the guys that are making very good libraries for Arduino and for us to use them very, very easy and without brain hurt too much. Okay, I will see what I can do next, and I will say goodbye for now, and see you next time. And yeah, all right. Thank you very much for watching. Thank you very much for your likings. Hit the like button there. And all right, bye bye from Q12, from our favorite artist electronics, Mr. Q12. Bye bye.